After talking about Azure DevOps environments in general, and then looking into specific implementation for virtual machines and Kubernetes clusters, it's now time for a deep dive into checks and gates. Let's take a look at all the checks and gates available in Azure DevOps environments and how we can use them for deployment control. Hi everybody, welcome back to CoderDave. Today we're going to talk about checks and gates that are available in Azure DevOps environments for controlling the release process. And this video is part of the series dedicated to Azure DevOps environments, series in which I've already covered the pipelines environments in general, as well as the specific implementation for virtual machines and Kubernetes clusters. I highly encourage you to take a look at this video if you haven't done it already. You can find the link up here and in the video description. In this video instead, we will go through all the checks and gates that are available in Azure DevOps environments, or at least all the ones that are available right now at the moment of recording, and we will see how we can use them to orchestrate our deployments. But before we start, make sure to subscribe to this channel if you haven't already, and if you want to learn more about DevOps, especially with Azure DevOps and GitHub, just click on the subscribe button below right now and turn on the notifications so you will not miss any new videos like these. Alright, let's start. There are currently 9 different types of checks that are available in the Azure DevOps environments: approvals, branch control, business hours, evaluate artifact, exclusive lock, invoke Azure functions, invoke REST API, query Azure monitor alerts, and require templates. I've already quickly touched on some of them in some previous videos, and perhaps you may be familiar with some others as well. So in the video description, you can find the timestamps for each of those checks that you can use to jump to them should you want to. But now let's jump into Azure DevOps. As you probably already know, we need to go inside an environment in order to be able to add checks and gates. So from here, approval and checks. And here we can click on the plus and add our check. Let's start with approvals, which probably is the most used ones. And what this does is allowing you to add approvers to your pipelines. And those approvers have the power to either reject or approve a stage to run. Let's add my user, for example. And you can also specify some instructions to the approvers, like approve only if all tests pass. You can also allow approvers to approve their own runs, which means that if I'm the one kicking off a pipeline, if this is selected, I can actually allow that to continue. Probably in bigger organization, you want to turn this off, so it's not a one-man band process. Then you can specify a timeout, which can be in days, hours, or minutes, meaning that if no approval is given within the timeout period, then the stage will automatically fail. Let's try this in action. I do have a pipeline over here, which I'll be using throughout the video, that targets that environment and contains 2 different stages. Let's run it. Stage 1 is a stage with no checks and approvals, while stage 2 is the stage that targets the environment where we just configure the approval and which we will use throughout this video. We can see that the stage 1 is executing. And now, after stage 1 is completed, stage 2 is waiting for approval. We can see over here that we have 1 check that hasn't passed yet. And we can also see over here that we need an approval before running the stage 2. And if I access the same pipeline with the other user, the user that is requested to approve, then I can review it. I can see the instructions over here, and I can either reject or approve the run. Let's approve it for the time being, and you'll see that the stage is now running. I can go back to the other user. Let's go in, and I can see that the stage is run. Of course, if I would have rejected it, the stage would be marked failed and then not run. I think this is a very straightforward check. Let's now remove the approval and add a branch control check. This check allows you to control the execution of your stages based on the branch linked to this particular run. You can specify the allowed branches, and you can use wildcards, as you can see here. You can specify a single branch or a comma-separated list of branches. Remember that this check requires the branch names to be fully qualified, which means you need to use the format as ref/heads/the branch name. In this case, for example, let's say we want to allow our stage to run only if the pipeline is linked to the master branch. We can also specify that we want to verify if our branches are protected, and we don't want to, for example, deploy if there is no branch protection in place. And once again, we can specify a timeout window. Let's create this. And let's go back to our pipeline. Let's run it again, but this time let's run it from this other branch I have and see what happens. We can see that the stage 2 is marked as failed because one check has failed. If we click on the check, we can see that the branch control failed, and if we click on it, we have more details, and we can see that the allowed branch is only master, while the branch connected to this pipeline run is actually this other branch, so the evaluation is unsuccessful. If we try to run this again, but from master, we can now see that the stage completed, and if we look into the check, we can see that the evaluation was successful because the branch where this pipeline comes from and the allowed branch is the same. Let's now move to the business hours check. Again, this is a very straightforward one, and I've actually covered this already in one of the previous videos. You can find the link up here and in the video description. But basically what these checks allow you to do is setting some deployment windows for your pipelines to run. For example, let's say you want to execute deployments or execute your stages only on Tuesday and Thursday. You would select only those 2 days. And you want to do it from, let's say, 9 a.m. to 1 p.m. in the UTC time zone. And once again, you can specify a timeout. Let's add this. Now I'm recording this video on a Wednesday, while we specify only Tuesday and Thursday as allowed days for this deployment. So if I try to run the pipeline right now, we can once again see that one check needs to pass before we can continue with stage 2. And if we check into this, we can see that the allowed days are Tuesday and Thursday from 9 a.m. to 1 p.m. UTC, while, as I said, we are running this on a Wednesday and actually even outside the time window. So the evaluation fails. Differently from other checks though, the failing of this evaluation doesn't make the pipeline fail, but rather it will just wait for the deployment window to open. Meaning that in my case, since once again it's Wednesday, it will wait until tomorrow to start the run. Let's go back to our environments and remove this check again. Next one is the evaluate artifact, which I think it's pretty cool. Now, with this check, you can evaluate artifacts to be deployed to an environment against custom policies. Remember that currently this works only with container images, but I believe there will be new features coming soon. So how does this work? First of all, you need to set a name, and then you can add in here your policy definition. You probably don't want to start writing all your policies by hand, so you can use templates. There are 4 different templates you can use, and actually, you can also mix and match them. I've now selected all 4 of them, and if I click on next, I can customize the parameters of those policies. For example, whitelist sources for my container images. For example, I may want to add only my private repos as possible source for my images. That would be newton.azurecr.io and hub.docker.com/newton. And I also selected the forbidden ports template. What I can do is make sure that the container images I publish don't use or don't open ports that are forbidden. For example, I don't want any of my container images to have the ports 21 and 22 open. The last one I selected is the possibility to have only images that are built using Azure pipelines. This template doesn't have any configuration, but it's pretty cool because it allows you to control where your images have been built, and in this case, allow you to deploy only images that you personally built using Azure pipelines. Let's click on next. All those templates are translated into actual policies, and in fact, we can see here the 2 registries we have specified, the 2 ports we have specified, and also that check for images to be built just with Azure pipelines. There are many other policies you can write yourself, and they follow the Rego format. Check the link here to know more about these policies. Let's see how this works. When you run a pipeline, as usual, the execution of that run pauses before entering the stage that uses this environment, and the specified policy is evaluated against the available image metadata. The check passes when all the policies are successfully evaluated against the artifact, and you can also see the complete logs of the policy checks from the pipeline view. If any of the policy fails instead, the whole check fails, and the stage is marked as failed as well. Again, you can also see the complete logs of the policy checks and the ones which failed from the pipeline's view. Let's go back to our environment and try to add the exclusive lock. This check doesn't have any configuration apart from the timeout, but it's a pretty interesting one. The exclusive lock checks, in fact, allows only a single run from the pipeline to proceed, which means that all stages in all runs of the pipelines which use the same resource or environment are paused. When that stage using this environment completes, then another stage can proceed to use that environment or resource. Also, and this is very important, only one stage will be allowed to continue. If there is any other stage which try to take the lock, they will be cancelled. Okay, we are halfway through our journey into the Azure DevOps Environments checks. But before we move on to my favorite ones and we start talking about functions and APIs, etc., hit the like button below if you think this video provides value to you or you find it insightful. Let's try now to add the Invoke Azure function. As the name says, this will allow you to call an Azure function and have that perform whatever you want before deployment. I created an Azure function for this, so I'm adding here the URL and the function key for authenticating to that function. You can select the HTTP verb you want to use. In my case, I want to use post. If you have any header that you need or want to use, you can add them here. You can specify query parameters and the body of the request. In my case, it's a very simple Azure function. I just need to specify if I want it to fail with this JSON body fail and true or false. Let's start with false, so we should be able to see our pipeline completing. If you go to advanced, we can change the completion event between API response and callback. In case the Azure function executes for more than 1 minute, then you'll need to use the callback completion event, because API response completion option is supported only for requests that complete within 60 seconds. And when you specify API response, you can also define your success criteria. If you leave it blank as it is right now, it will just take the HTTP 200 status code as success and every other HTTP status codes as failure. But if you want to have something more specific, for example, evaluating something in the response of your API, you can add it to this field. And as usual, we can specify a timeout, and we can specify also a time between evaluations. If the Azure function fails, this check automatically retries the number of minutes you specify here. This could be useful, for example, if you're waiting for something to call the start, or if you want to avoid transient errors. In my case, I just want to put 1 minute between evaluations and 1 minute timeout. And this will ensure me that this Azure function is executed only once, because after failing, the system will want to wait for 1 minute, but then it will reach the timeout, and so everything will fail. Let's create this and let's start our pipeline. And as we see, the job completed. If we take a look into the check, we'll see that the Invoke Azure function check as passed. And the response code is okay. If we go back to our environment and we change the check to fail, I just need to change this to true, and we try to execute the pipeline once again, we should see this failing. We can take a look at the check and we see that it is in progress. We now see that the stage is being skipped because the check hasn't passed. And this is important. The stage will not fail if the check fails, but rather will be skipped. If we take a look at the check, we see that it timed out. But if you take a look closer, we see that the attempt to invoke the Azure function has actually failed because the Azure function returned the HTTP 400 status code, which is what my Azure function is designed to do if you pass the fail through request body. The reason why in the check it says that this has timed out is because, as I mentioned before, the system is designed to retry the invocation as many times as possible before reaching the timeout window. In my case, the timeout window was only 1 minute, and I had a waiting time between retry of 1 minute, so it has been executed only once and then it timed out. And this is very similar to what happens when we set a check for invoking an API. Let's delete this and let's add the Invoke REST API. The big difference here is that you're not going to specify an URL, but instead you need to create a service connection to point to your API. And this can be either a generic service connection or an ARM service connection. In my case, it's a generic, and I have this my API. And this service connection is where you're going to specify the URL, the authentication for your API, if any, and so on and so forth. All the rest is basically the same. You can choose a method, you can specify your headers, and add your body. Once again, my API uses the same style of body with the fail, false, or true. Differently from the Azure function though, you can specify URL suffix and parameters that you want to pass to your API. And once again, you can have API response or callback as completion, and you can define your own success criteria. And again, you can change the time between evaluations, and you can also change the timeout. Once again, I'm putting 1 minute and 1 minute because I want that to be executed only once. Let's create this. Once again, start our pipeline. The check passed and the stage completed. We can see the Invoke REST API as passed because the response code was okay. Very quickly, let's change that to true to make the API call fail. And once again, we can see that the stage has been skipped because the Invoke REST API check has timed out. And again, if we go inside, we can see the error 400 that my API is designed to return whenever we set fail to true. So as I said before, also in this case, the stage is skipped, it's not failed. Let's now talk about the query Azure Monitor alerts. I want to spend a moment talking about this because I think the documentation is a little misleading. If we read the part highlighted here in yellow, in fact, it says that Query Azure Monitor Alerts helps you observe Azure Monitor and ensure no alerts are raised for the application after a deployment. Reading this may lead you to think that this check is executed after the stage completes, while in reality is still a pre-deployment check. What you can do to make sure your application that you just deployed is working correctly is adding this check to a step after your deployment and then evaluating the Azure Monitor alerts in there. Okay, now that we have this clear, let's go back to Azure DevOps. Let's configure this. First of all, you will need to select an Azure subscription. And this can come from a service connection or directly from a subscription. And after that, you will need to pick a resource group in that subscription that you want to monitor. With this setting, Azure DevOps will connect to Azure Monitor in your subscription and check if there is any alert or any error for the resources in this resource group. But perhaps you don't want to monitor all the resources in that resource group. So we can go to Advanced and specify a filter by either resource or by alert rule. If we specify by resource, we can select a specific resource that we want to monitor inside that resource group. And if it's by alert rule, then we can pick an alert rule we've created previously in Azure Monitor. I don't have any now. You can also filter by severity. By default, all 5 severity levels are considered, but let's say you want to focus only on severity 3 and 4, you can do so. You can filter by time range, and that can be any alert generated in the last hour, in the past 24 hours, in the past 7 days, and in the past month. You can filter by alert state. By default, you have new and acknowledged selected, but if you want only the new, or if for some reason you want to add the closed ones, you can again do so. And finally, by monitor condition. And this basically allows you to check if the underlying alert has crossed the defined monitor rule threshold. As for the others, you have time between evaluation and timeout. And finally, we have the last check here, require template. With this check, you can enforce pipelines to use a specific YAML template, and when this check is in place, a pipeline will fail if it doesn't extend from the reference template. You can just add a required template and select where your templates is. Could be in Azure repo, in GitHub, or in Bitbucket. You then need to specify the name of the repo where your YAML template is, the branch that contains it, by default is the master one, but you can specify any branch you want. And finally, the path to the required YAML template. This is a very powerful check that allows full control on your pipelines because especially in enterprise scenarios, but not only, you want to be sure to have some specific steps, for example, in your workflows, and this is the way you do so. Let's say, for example, that I want to add a template in the templates project under the My Templates repo from the master branch, and the YAML file is in the security folder and it's called scan sources YAML. When I do so, you can see that I can add more templates. And let's add, for example, this governance as called YAML template. The interesting part of this check, as this message say, that the pipelines that are using this environment and therefore triggering this check must extend at least one of the templates specified above. If you instead want both of those templates to be referenced from your pipeline, you will need to create multiple required YAML templates check, each with one of these templates. Few general notes before closing. First of all, you can take advantage of multiple approvals and checks in the same stage. You just need to add more than one to your environment, and remember that all of them need to pass successfully for your stage to run. Another thing to notice is that only predefined system variables are available into the checks. If you want to evaluate a variable that is being produced by a previous stage, then you need to write that variable in a variable group and associate that variable group to the check. Then it's when you will be able to read that variable inside the check. Finally, remember that all the checks and approvals in the YAML pipelines are pre-deployment approvals and checks. There are no post-deployment checks and approval and gates, like for example there are in the classic pipelines. If you want to see an in-depth comparison between YAML pipelines and classic pipelines, you can check the link up here and in the video description. Alright, that's it for today. We should have now a quite good understanding of all the checks and approvals that are available into Azure DevOps environments and how we can use them for controlling our release process. Let me know in the comment section below if you have additional questions about them. In the video description you can find the timestamp checks and gates available in Azure DevOps code spaces. No. Thanks so much for watching. I really hope you enjoyed it. Hit the like button below, subscribe if you haven't already, and I see you in the next video here at CoderDave.